Hey everyone, welcome back to JavaFlair. In today's session, we are diving into one of the most fundamental topic in Java, that is nothing but operators. Operators are like the magic tool that lets us perform calculation, make decision and control the flow of your program. Without them, programming would be incomplete. So let's get started. Operators in Java are symbols that tells the compiler to perform specific operation on a variable and a value. For example, a plus b is telling that perform addition of two numbers that is stored in variable a and b. A greater than b will compare whether a is greater than b or not. And a double ampersand b checks the condition whether both of them are true or false. Now let us try to understand all the types of operators that are present in Java. First one is arithmetic operator. Second one is assignment operator. Third one is comparison operator, which can also be called as relational operator. Fourth one is logical operator. Fifth is bitwise. Sixth one is unary operator. Seventh one is ternary operator. Eighth one is instanceof operator. Let's go through each one with example and try to understand them in a more detailed manner. Let's try to understand what exactly is arithmetic operation or operator. This is one of the most basic operation or operator that is used to perform all basic mathematic operations such as addition, subtraction, multiplication, division and modulus. For performing addition between two numbers, we'll be using plus symbol. For performing subtraction, we'll be using minus symbol. For performing multiplication between two symbols, we'll be using asterisk. For performing division, which is nothing but we'll be retrieving the quotient of two divided numbers, we'll be using slash. For modulus, which is nothing but we'll provide the remainder after dividing two numbers. For that, we'll be using a percentage symbol. To understand this concept in a more detailed manner, let's go back to IntelliJ and do the following. I am creating a class called Arithmetic Demo, and in this I'll be creating two variables, int a is equal to 10 and int b is equal to 3. Let me print all the operations to the screen and perform the operation as well. First I'll be doing addition, so I'll type system.out.println a plus b. In the next line I'll be entering or I'll be performing minus operation, which is nothing but subtraction. I'll enter system.out.println a minus b. In next line, let us perform the multiplication. System.out.println a into b. In the next line, let's do division and see actually what will be the result. System.out.println a divided by b. Last operation, that is nothing but modulus, which gives us the remainder. Make sure you know the difference between division and the modulo operator. System.out.println a modulo b. Now let's save this program and see what actually happens. Okay, let me now compile the code. You can see that for addition it is printed as 13. For subtraction it is printed as 7. For multiplication it is printed as 30. For division it is printed as 3. And for modulo it is printed as 1. Pretty straightforward, right? Now let's move to next operator, that is nothing but assignment operator. Basically, they are used to assign value to a variable. To simply assign a value, we would use equals. But in assignment operators, we would be using plus equal to for addition assignment, minus equal to for subtraction assignment, and into equal to or asterisk equal to for multiplication and then assigning. For division we would use slash equal to. For modulo we would be using percentage equal to. Let us try to understand this by actually performing the operation. This is nothing but a short form which is used to represent x equal to x plus the operation we want to perform, which is nothing but in the short form we are writing it as x plus equal to the value that we want to add. Go back to IntelliJ and perform the assignment operators over there so we can get to know how actually they work in a more better way. I'll be creating another class called assignment demo, and here I'll be declaring a variable of type integer int x is equal to 5, which is nothing but x value is initially set to 5. Now let me print this value to the screen as well as perform the operation so we can actually see what actually happens after performing the assignment operation. So I'll be entering system.out.println x plus equal to 3, which is nothing but x equal to x plus 3, which we have written it in the short form as plus equal to. Let's now perform the multiplication operation. System.out.println x into equal to 2, which is nothing but the short form of representation of x equal to x into 2. Now let me save this program and see the output. Okay, now we can see that the addition is printed as 8 and the multiplication is printed as 16. This helps us reduce the repetition or replication of same code again and again, which makes the code optimized. Let's move to the another operators, that is nothing but comparison operator. Comparison operators are also called as a relational operator. This returns the boolean value to the screen, which is nothing but it can either be true or it can be false. Now let's see each one of them in a detailed manner. Double equals to is used to check whether the first value is exactly equal to second value. If it is equal, it returns true. If not, it returns false. Not equal to is used to see whether first value is not equal to second value. If they both are different, then it returns true. If not, it returns false. Greater than is used to check if first value is greater than second value or second value is greater than first value. Less than is used in the same manner. Greater than equal to will also check if it is greater or is it equal, and less than also works in the same way. To understand them in a better way, let's go back to IntelliJ and actually perform this operation, and let's see. I'll be creating a class called comparison demo. In this class, I have two variables, that is int a is equal to 10, int b is equal to 20. I'll be performing greater than and less than equal to operation. Let's do this by actually printing it so we can see whether it is true or false, how it actually works. I'll be entering system.out.println a is greater than b. In the next line, I'll perform the same operation but for less than equal to. System.out.println a is less than equal to b. Now let me save and compile this program. Okay, now you can see in the console that a greater than b is printed as false because 10 is not greater than 20. But in the next line, we can see that it is printed as true, which is nothing but less than equal to. Yes, of course it is printed as true because 10 is always less than or equal to 20. It is true, right? Let's try to understand what actually is a logical operator. Logical operator are often used in checking conditions. Double ampersand is used for performing AND operation, which is nothing but if both the results or both the variables has true value, then only it returns true. If either one is false, then it returns false, no matter what another variable value is. Next one is OR operation, where we'll be using double pipe like symbol. This returns true if either one is true. Even if one is false, it doesn't affect the result. Single exclamation used to perform not operator, which is nothing but it inverts the result. If you give true and then apply not operation, then it returns it as false. If you give false and then perform the not operator, then it returns true. Let us try to understand this in a better way by using IntelliJ. In IntelliJ, I'll be declaring logic demo as a class, and in this logic demo, I have a variable int age is equal to 25. Let us see how it works by printing all the statements. System.out.println age is greater than 18 and age is less than equal to 30. In next line, let's perform OR operator. System.out.println age is greater than 30 or age equal to 25. In next line, let's perform the last operation, that is nothing but not. System.out.println not of, which is nothing but an exclamatory mark, open the bracket, age is greater than 18, close the bracket. Let me now save and compile this program. You can see for first one it is printed as true because the value we assigned for the variable age is 25. So age is greater than 18. Of course it is greater than 18. Along with that, age is less than 30. 25 is less than 30, right? Yes. So both the condition are true. So we can see that true is printed to the console. In second operation, we have performed OR operator where we are checking 25 is greater than 30, it is false. But age equal to 25, it is true. False or true will always give you true, no matter whether one is false or not. If both are false, then only it is considered as false. If not, either if one is true, it is true. In last operation, what we checked was, of course, a true value because 25 is greater than 18. But after performing a not operation, it is printed as false because we are reversing or we are inverting the result. So for this purpose, we'll be using not operation. Let's try to understand one of the most important programming operator, that is bitwise operator. This is one of the advanced one, but they are mostly used in most of the platform oriented problem solving, and they help us solve the problems in a more efficient and less time complexity as well as space complexity. So understanding them matters a lot. Try to understand this concept in a better way. Bitwise operation or operators only work on binary representation of numbers. So we can only perform this operation on binary numbers or binary representation. So only it is called as bitwise. Let's try to understand them in a more detailed way. Single ampersand is used for performing AND operation. Single pipe like representation is used to perform OR operation. XOR is nothing but a power symbol. Tilde is used to perform the NOT operation in bitwise. Double left angular brackets are used for left shifting the bits, and double right angular bracket are used for right shifting the bit, and triple right angular brackets are used to perform unsigned right operation. Let's move to IntelliJ and try to understand them in a good way. I'll be creating a class called Bitwise demo. I have declared two variables, int a is equal to 5 and int b is equal to 3. These are two numbers. In binary representation, we can write them as 0, 1, 0, 1. And for 3, we can represent it as 0, 0, 1, 1. First, let us perform the AND operation. What happens over here is, if both value after comparing, if both have 1 1 in the same place, then it returns as true, or 1, if not it returns as false. System.out.println a ampersand b, which is nothing but used to perform the AND operation. System.out.println a or b, which is nothing but OR operator. System.out.println a XOR b. system.out.println tilde a, which is nothing but a not operator, system.out.println a left shift by 1. Now let me save and compile so that let's trace this each value and see how actually it works. So now you can see that for AND operator it is printed as 1, for OR it is printed as 7, for XOR it is printed as 6, for NOT of A is printed as -6, for left shift of A by 1 is printed as 10. Let's first try to understand how 5 is represented as 0, 1, 0, 1 and 3 is represented as 0, 0, 1, 1. These numbers are created by keeping the power value of 2 will initially start from 0 and will keep incrementing the power by each one value, which is nothing but 2 power 0 is the first value, 2 power 1 is the second value, 2 power 2 power 3 is the third value. 2 raised to 0 is nothing but 1. 2 power 1 is nothing but 2. 2 power 2 is nothing but 4. 2 power 3 is nothing but 8. If we want the value as 5, then check which all values you need to set it as 1. So adding 4 and 1 will give you 5, right? So other than 2 power 2 and 2 power 0, make all the bits as 0, which is nothing but 0, 1, 0, 1. So we can say 5 bit representation is 0, 1, 0, 1. In the same way, for 3, if we want the total value as 3, then we'll be setting 2 power 0 and 2 power 1 as 1, 1 and all other bits as 0, which gives us the final result as 3, 0, 0, 1, 1. Now let's try to understand why the value is printed as 1 when we performed the AND operation. So let us write the first variable value, that is nothing but 0, 1, 0, 1, and the second value is 3, which is nothing but 0, 0, 1, 1. What is the basic criteria for performing AND operation? Think for a second. Okay, now let me explain. AND operation basically gives the value as true only when both the bits are true. If not, no matter if one is false or true, it gives us false value only. If both the bits are true, then only it gives us true. So we can see first in 5 also, in 2 power 0 position we have 1, and for 3 also we have in 2 power 0 position 1. So 1 and 1 will give us 1. In 2 power 1 position for 5 we have 0. But for 3 we have 1. 0 and 1 should always be 0. For 2 power 2 position for 5 value we have 1. But for 3 we have 0. So 1, 0 is 0. 0, 0 is always 0. So if you see now, 2 power 0 is set as 1 and all 3 bits are set as 0. So 2 power 0 is nothing but 1. So only the final value is printed as 1. So now let's try to understand the OR operation in the similar way. First bit is 0, 1, 0, 1, which is nothing but the actual bit representation of 5, 0, 0, 1, 1, the bit representation of 3. The OR operation main criteria is even if one value is true, it will return as the final value also as true. If either both of them are false, then only it returns false. First 2 power 0 bit, in 5 also we have 1, in 3 also we have 1. So this bit is considered as 1. In 2 power 1 position, for 5 it is represented as 0, but for 3 it is represented as 1, which is nothing but 0 or 1 is nothing but 1. For 2 power 2 bit or 2 power 2 value, for 5 it is 1, for 3 it is 0. 1 or 0 is nothing but 1. But in last position, we can see both the bit has, for 5 as well as for 3, both of them contain 0. It always returns 0. So the actual final representation is 0, 1, 1, which is nothing but 2 power 0 is 1, 2 power 1 is 1, 2 power 2 is 1, and last 2 power 3 is only set as 0, which is nothing but 1 plus 2 plus 4. The total value is 7. Make sure you also practice by taking few questions so that you can understand this concept in a more better way. As a programmer, bitwise operations are more important. Now let's trace the value for XOR operation. The main criteria for XOR operation is if both the value are 1 1, or if both the value are 0 0, or if both the bit are same, then it returns false. If one contains true and if another bit contains false, then only bit representation of 5 is 0 1 0 1. The representation of 3 is 0 0 1 1. In 2 power 0 position, we can see both the bit are 1, which is nothing but according to XOR operation, it is considered as 0. But in 2 power 1 position, for 5 we have 0, for 3 we have 1. 0 or 1 will always return as true, which is nothing but 1. In 2 power 2, we can see for 5 we have 1, and for 3 we have 0, which is nothing but 1. For 2 power 3 position, we have both the values as 0. So it is nothing but 0, as both of them are same. So the final result is 0 1 1 0, which is nothing but 2 power 0 is set as 0, 2 power 1 is set as 1, 2 power 2 is set as 1, and 2 power 3 is also set as 0, which is nothing but 2 plus 4. The total answer is 6. So only it is printed as 6. I would like to give you one simple homework problem. That is nothing but I want you to trace for not of A and drop a comment. Now let me trace the value of A left shift by position 1. The actual representation of A was 0 1 0 1. We are saying the Java to left shift the value by 1. Left shift is nothing but it will remove the left value depending on the left shift number we have specified, and it will add the number of removed values from left to the right position with 0 values, which is nothing but I will be removing one value from left, which is 0. So the result will be 1 0 1. I'll be adding the same number of removed value from left to the right in the form of zeros, which is nothing but 1 0 1 0. In left we removed one value as we have specified left shift the 5 by 1. So another additional 1 means total shift we did those many numbers of value of zeros will be added to the right. So 2 power 0 is set as 0, 2 power 1 is set as 1, 2 power 2 is set as 0, 2 power 3 is set as 1. So 2 power 1 is nothing but 2, 2 power 3 is nothing but 8, 8 plus 2 is nothing but 10. So this is the final result that we have got over here. We will generally be using these operations in system level or optimization task. So make sure you understand them in a more better way. Now let us try to understand another operator, that is unary operator. This applies to single value, which is nothing but unary plus for positive representation of numbers, unary minus to indicate that the particular number is a negative, plus plus is nothing but to indicate it is incrementing, minus minus is used to represent decrementation, not is used for logical not. Let us try to understand them in a more detailed way. But I hope that you have seen plus plus and minus minus most probably in loops, where we'll be writing I plus plus, which is nothing but the short form representation of I equal to I plus 1. Let's go back to IntelliJ. I have created a class called Unary demo, and in this class I have created a variable int n is equal to 5. Let me now print the value and also perform the operation. system.out.println plus n. In incrementation and decrementation, we have two types of incrementation and decrementation: prefix incrementation, postfix incrementation, prefix decrementation, and postfix decrementation. Out.println plus n, which is nothing but prefix, where we are actually first incrementing the value and then I'll print the value. But in next line, system.out.println n minus minus, which is nothing but postfix decrementation, which is nothing but first I'll use the value which was previously present and then I'll decrement. If system.out.println minus n, which is nothing but I'm setting the value of n as negative value. So now let's save this program and compile it and see. Okay, now you can see in console that prefix incrementation is printed as 6, which is initial value of n was 5. But what we did was we first incremented the value of n. So n became 6 and then it is used to print. So it is printed as 6. But you can see in postfix decrementation, the value again it is printed as 6 because first I'll be printing the value, then I'll be decrementing it. So n is printed as 6 initially and then it is decremented to 5. In next line we can see that it is printed as minus 5 because after decrementing from 6 it becomes 5 and we have set the sign of number as negative, so it is printed as minus 5. Hope you are understanding the concepts. If not, please give a pause and try to analyze them and actually understand them. They looks like more simple, but understanding them gives us the most important grip that all of us need to have as a programmer. Now let's try to understand ternary operator. Ternary operator is basically a short form representation of if and else. This works like similar to if and else. If the condition is true, execute some logic, else execute some other logic. Instead of writing the statements in 3 lines, we'll be performing them in a single line. Let's try to understand them in an actual theoretical way. First, we'll be using a condition and then we'll separate it with question mark. If this condition is true, then print the value that is present after question mark. If the condition is false, then print the value that is present after 2 colons. So let's try to understand it in a more detailed way by going back to IntelliJ. Here I have created a class called Ternary demo and I have created two variables, int a is equal to 10 and int b is equal to 20. Int maximum is equal to a greater than b question mark a colon b. System.out.println max. Here I am trying to print which number is maximum. Okay, let me save and compile this program. You can see the maximum is printed as 20. Now let's try to understand what actually happened. So the maximum value we got is 20. First we are comparing a is greater than b. The initial value of a is 10 and the initial value of b is 20. Is 10 greater than 20? False, right? So it tells the Java that don't print the value that is present after the question mark. Print the value that is present after colon, which is nothing but 20. This is what we are operation performing over there, right? If a is greater than b, then only print a. If not, print b. As we got to know, 10 is not greater than b, so the value of b is printed instead of a. Super useful for short conditions, right? Now let's try to understand one last operator, that is nothing but instanceof operator. It checks whether an object belongs to that specific class or not. It prints true or false, which is nothing but a boolean value. Let's directly go to IntelliJ and try to understand this. I'm creating a class called instanceof demo, and here I have created a variable of type string s is equal to Java. System.out.println s instance of string. Let me save and compile this. Okay, now in the console you can see it is printed as true because of course string is an instance of class string, so it is printed as true. If I would have given as instance of integer, then it would have returned false because string is not an instance of integer. Let's try to understand that in a more detailed way when we go for OOPS concepts. But for now, try to understand the simple concepts like how actually it is printing, how it is working. Let's now use all the operators and do one coding question. I'll be creating operators demo class. Here I have a main method, public static void main string args. Int a is equal to 10, int b is equal to 20, which is nothing but I have created a variable of type int, and a value is assigned to be 10, b value is assigned to be 20. First let's perform arithmetic operation. Int sum is equal to a plus b, int product is equal to a into b. Now I am again creating another variable and setting the value as 5. Int x is equal to 5, x plus equal to 10. Now let's perform comparison operator. Boolean is greater is equal to a greater than b. Let's perform logical operation. Boolean is range is equal to a greater than 5 and b less than 30. System.out.println sum is equal to plus sum. System.out.println product plus product. System.out.println updated x plus x. System.out.println is a greater than b plus is greater. System.out.println is a in range a greater than 5 and b less than 30 plus in range. Let's try to analyze the result by saving and compiling the code. We can see in console sum is equal to 30, product is equal to 200. So after incrementing x value is printed as 15. After comparing a and b, is greater is nothing but false because 10 is not greater than 20. Is a in range of greater than 5 and b less than 30 is printed as true because a is nothing but 10. 10 is greater than 5 and 20 is of course less than 30. So both the condition are true. Performing AND operation gives us true. Now let me test to what extent you have understood the concepts of operators. I'll be giving you one practical question. So try to solve this on your own. After completing solving questions, drop a comment so that it helps us and motivates us to create more such videos. First question is, write a program to calculate the total price of 5 times with a 10% discount. Second is, compare two numbers and print whether first is larger, smaller or equal. Check if number lies in range using logical operator. I hope this video was helpful. If you like this video, please make sure you like, share and subscribe. Please visit our JavaFlair website and keep learning. We have actually provided more resources like notes, detailed theory concepts, place to debug your code and understand them in a practical way. Thank you.